Coulomb's law. Today we will discuss Coulomb's law. It's a very simple law. I'll try to explain the Coulomb's law with the help of these two magnets. Everyone knows there is force between the magnets. The force can be attractive or repulsive. Coulomb's law tells us about the force between the charges, not a magnets. Okay, I'm trying to explain with the help of these magnets. Here, the force is increasing by decreasing the distance. I'm decreasing the distance between the magnets. The force is increased. And I'm increasing the distance, the force is decreased. There is no force between the no magnets. Now, by decreasing the distance, the force is increased. Means, force has inverse relation with the distance. Inverse relation means, if one quantity increasing, the other is decreasing. So, it's mean they have inverse relation with each other. Same here. Now, the distance is increasing. The force is decreasing. Means, force and distance has inverse relation. Means, the force R is a distance between the magnets or the charges. Force has inverse relation with the distance. R is a distance. With the other thing. Now, I'm taking the smaller one. These two magnets has weaker force between them because of this small magnitude of the magnet. And these two magnets has greater force. Now, I increase the magnitude of the magnet. The force is increased. It means it's a direct relation. Direct relation means if one quantity is increased, the other is also increased. It means they both have direct relation with each other. So here I increase the magnitude of the magnet. The force is now increased. Now I'm decreasing the magnitude, the force is also decreased. It means force has direct relation with the magnitude. Greater the magnitude, greater will be the force. Means force has direct relation with the magnitude of the charges. Means with the magnitude, force has direct relation. Greater the magnitude of the magnets or the charges, the force is greater or stronger. Smaller the magnitude, weaker will be the force. It's a Coulomb's law. Two things. Force has inverse relation with the distance, the force has direct relation with the magnitude of the charges. It's all about the Coulomb's law. Now, what is this? It's a story which moves around this concept, which I'm explained already. Now, look here, Coulomb's law. This law tells us about the force between the charges. Now, one thing, the Coulomb's law is not for the magnets. The Coulomb's law is for the charges. I'm giving the example of the magnets because everyone knows or have experience of the magnets in daily life. So that's why I'm trying to explain with the help of magnets. Now, Coulomb's law is not for the magnets, it's for the charges. Charges play same roles. Here if I'm increasing the distance, the force is decreasing between the charges. And by increasing the magnitude, the force is increasing. Greater the charges, greater will be the force. It's a Coulomb's law. Coulomb's law states that the force between 2 point charges is directly proportional to the product of the magnitude of charges and inversely proportional to the square of distance between them. These both are written in the theoretical form, here mathematical form. Now, by combining these two inequalities, now here comes Coulomb's constant. K is a Coulomb constant for free space. Now, if I am putting any marker any dielectric between the charges. It's a dielectric. Dielectric can be plastic, glass, water, etc. No, it's a common sense. If I'm putting the marker, the force of Q1 on Q2 decreased, or if I'm putting the marker between these two magnets, the force of this magnet or this one is, it's a common sense, it will be decreased. If I'm removing, the force is now increased because there is no barrier between the magnets. Same here, if there is any dielectric, this marker will be a dielectric if I'm putting here between the magnets or between the charges. The force increases. K is the Coulomb constant. The value of K depends upon the dielectric for free space. The K value for free space or vacuum, the K is 9 multiplied 10 power 9 Newton meter square per Coulomb square. Or K, the value of K 1 over 4 pi epsilon naught. Epsilon naught is the permittivity of free space. Permittivity means permission. The free space permits this magnet, this charge to apply a force on this one. It's a permittivity for free space is the epsilon naught. The value of, for free space, the value of epsilon naught is 8 multiplied by 8.85 multiplied 10 to the power minus 12 Coulomb square per Newton meter square. Now Coulomb's law in different materials. In different materials means in different dielectrics. In plastic, in glass, in water, etc. So in any dielectric, I am putting a marker and it's a dielectric between the charges. So the force will decrease. It's a common sense I am putting. It's a common sense. I am putting marker over here. The force of Q1 on Q2 will be decreased. If I am removing, the force of Q1, Q2 is increased. So in a material, the force will be decreased. When there is dielectric between the charges, the force, dielectric means a marker, a glass or water. The force decrease by the factor epsilon r. Epsilon naught is the permittivity for free space. Epsilon r is the relative permittivity of this marker, this material with respect to vacuum, with respect to this one. Now, by putting the value of K here, force becomes 1 over 4 pi epsilon naught of, in material 1 over 4 pi epsilon naught epsilon r. Epsilon r is the relative permittivity of the dielectric. For vacuum, epsilon r is 1, for air 1.006, there are no units. For water, it's 78.5. Now, here epsilon r has no units, but epsilon naught has the units of Coulomb square per Newton meter square. But epsilon r has no units because epsilon r is the ratio of two similar quantities. I'm trying to explain here. For example, 10 meter over 2 meter. 2 1s are 2, 2 5s are 10, and the meter with meter will be, they both will be cancelled. Only 5 is left with no units because meter is cancelled with, it's a units because 10 meter and 2 meter both are two similar quantities. So the ratio, we can say the ratio of 10 meter to 2 meter. For example, 2 ratio 3, we write it 2 divided by 3. So 2 divided by 3 means 2 ratio 3. It's a ratio of two similar quantities, so the units will be cancelled out with each other, having no units. Similarly, epsilon or the ratio of epsilon to epsilon naught, so the units will be cancelled out and the epsilon r has no units. That's why here there is no units. Epsilon r is the unitless and dimensionless, having no units then having no dimensions also, because it is the ratio of two similar quantities. Now come here, epsilon epsilon naught, epsilon r is taken as epsilon. Epsilon is equal to epsilon naught, epsilon r. Epsilon r naught will be divided over here. So epsilon r is the ratio. Now the limitation of Coulomb's law. Every law has some limitations. Here Coulomb law also has some limitations. The first limitation is the point charges. What does it mean? Point charges mean the points that are on a single point. They can't move to the next point. Means they are at rest. Point charges mean the charges that are at rest, that are at single point. Means at rest. The second thing, there must be a distance equal to the radius of either charge. For example, it's a positive charge and negative charge. If there is no distance, the positive and negative will become a neutral. Now there is no charge and there will be no force. So Coulomb law is not applicable. Coulomb law, then the limitation is this: there must be at least a distance equal to the radius of either charge. First thing, charge must be at rest. Second thing, must having a distance equal to the radius of either charge. And charge must be concentrated on the center. This law works for the charges which are at rest, means that are at single point, and having distance at least equal to the radius of either charge. And this charge also works for, this law also works for the isolated sphere. Now it's a sphere, isolated sphere having charges on this surface. Coulomb law is applicable if I am taking point outside this sphere, over here, out of this sphere. The Coulomb law is applicable. If I am taking the point inside the sphere, the Coulomb law is not applicable. I am repeating three things. First, at rest. Second, having distance at least equal to the radius of the charge. Second thing, isolated charge sphere. Coulomb law is applicable if the point is outside the sphere. Now the vector form of Coulomb's law. Coulomb's force has both magnitude and direction. Now here we discussed only magnitude. There is no arrow, no unit vectors. If I am putting arrow here, there will be a unit vector. R1, R21 is a unit vector, and F12 is a force on 1 by 2. 1, 2 means force on 1 by 2. F12 is a force on Q1 by Q2. Then R21 is a unit vector. Force on Q1 by Q2. The direction of force will be over there. And the unit vector 21 is the direction of from Q2 to Q1. R1 to 21 is the unit vector from Q2 to Q1. Similarly, F21 force on Q2 by Q1. The direction will be in this direction. And R12 is the unit vector. There here a unit vector, here we put the arrow. Now these two forces 1, 2 and 2, 1 are equal in magnitude but opposite in direction. They are in accordance with the Newton's third law of motion. Newton's third law says that action and reaction are equal in magnitude but opposite in direction. So both forces are equal in magnitude but opposite direction. F12 and F21 are equal in magnitude, and Manes says that they are opposite in direction. So it follows the Coulomb's law. Now here I am explaining the units Coulomb square per Newton meter square and the units Newton meter square per Coulomb square. By finding the value, R square will be multiplied with the force, Q1, Q2 will be divided, and the value of K is F R square over Q1, Q2. Now the force is measured in Newton, R is the distance which is measured in meter, Q is a charge which is measured in Coulomb. Two charges, Coulomb square, R has square, the meter also has square. So the unit of K is Newton meter square per Coulomb square. Here The unit of K is Newton meter square per Coulomb square. Now the units of epsilon naught. Now K is equal to 1 over 4 by epsilon naught. Epsilon naught will be multiplied over there and K will be divided over here. Now 4 has no units, pi has no units, they both are constant quantities. The units of K, the unit of K is Newton meter square per Coulomb square. The one will be same and the units of K is Newton meter square per Coulomb square. The C square will be multiplied with the 1. So the units of epsilon naught is the Coulomb square per Newton meter square. The unit of epsilon naught is the Coulomb square per Newton meter square. That's all about the Coulomb's law.